Hello friends, welcome to Suresh Aggarwal's Mathematics Shortcuts. One of the topics in which the students find a little difficulty is how to enlist all the factors, that means the perfect divisors of a number, maybe a 2 digit, 3 digit, or even a 5 digit, 6 digit numbers. So, very important for all the class 6, 7, 8 students, and obviously for the number system part of the quant exams, finding the factors and enlisting the factors of a number, and how many maximum factors are there for a particular number. You can't escape this particular topic. So in this video I am going to tell you a method, you may call it a trick, to enlist all the numbers which are factors of a big number, and I'm telling you the shortest method to find the number of factors. That means you don't miss out on any of the factors of a given number. So watch the complete video. This is something very useful, and if you have not clicked the subscribe button till now, please do it right now, and don't forget to click the bell shaped icon so that you keep on getting all the notifications of these useful uploads on this amazing channel. So let's first understand the logic by taking a small number, and then slowly we will increase the number, and you will see how beautifully we are able to apply the trick to large numbers also. So for simplicity's sake, I am taking the first example. Okay, you need to watch the complete video. Right. Suppose I am talking about the number 12. The first thing you have to do is to find how many factors are there so that you don't miss out on any of those. For that, I'll be making the prime factors of 12. 12 is 2 times 6 and 6 is 2 times 3, right? Write it in exponential form. 2 is 2 square because it exists 2 times, and 3 is alone, so 3 raised to power 1. And so the number of factors of 12 will be, take the exponent to increase it by 1, and then other bracket, take this exponent 1, increase it by 1 and multiply the 2. So you will get 3 times 2, that is 6. That means when you make or enlist all the factors of 12, you are going to get 6 factors. Let's see what are those 6 factors. And before we write the 6 factors, we have to understand one more important thing. See, number of factors here are even. What does it mean? Even means we will be splitting the number of factors into two parts. I'll put a slash here. 1 is a factor of all numbers. So corresponding to 1, you will write 12 here, because 1 times 12 is 12. So we have enlisted two factors, and you will always enlist the factors in pairs like this. 12 is divisible by 2 also, and 2 times what is 12? It is 6. So we have enlisted two more. Now 12 is divisible by 3 also, and 3 when we multiplied by 4 gives you 12, and that's it. Between 3 and 4 you don't have any whole number, and therefore you don't need to check further. So you got 1, 2, 3, 4, 6 and 12, which are factors of 12, and there are 6 factors. This is the basic logic. Now I am going to increase the value of the number, and you will see how beautifully the trick works. So for the next example, I am taking the example of say 48. Now first thing is make prime factors. 48 is divisible by 2, so 2 times 24. 24 is divisible by 2, gives me 12. Another 2 gives me 6, and another 2 gives me 3, right? So these are the factors, the prime factors. Convert it into exponential form, 2 raised to power 4 and 3 raised to power 1. So the number of factors of this number 48 will be, take the exponent, increase it by 1, take the exponent, increase it by 1, and you have 10 factors of 48. Now one thing is for sure, you are not going to miss out anything, because you know you have to enlist 10 factors. Now 10 is an even number, so you will split it like this, and then start with a 1, and in the end you will have the 48, because 1 times 48 is going to give you 48. Then 48 is divisible by 2. Corresponding to 2, you will write 24, because 2 times 24 is again 48. Divisible by 3, 16 times 3 is again 48. Divisible by 4, so 4 times 12 is again 48. And divisible by 6, 8 times is again 48. So you can see pairs. All of these are going to get multiplied and give you 48 as the result, and you're not going to miss out anything. 6 and 8 has a 7 between them, and 7 does not divide 48, right? So the 10 factors have been enlisted without any error. Now, where does the situation get more complicated? You know, when the number becomes a 3-digit or a 4-digit number. Let's see whether we can enlist the factors further or not, or at least find out the total number of factors. If there are 40-50 factors, nobody is going to ask you to enlist all of them. They'll only ask you how many factors are there. Okay, so let's see the third example, that of say 1000. Okay, 1000 is an easy number. 10 times 10 times 10, so 2 times 2 times 2, and 5 times 5 times 5, right? Now this is 2 raised to power 3 and 5 raised to power 3, and therefore the number of factors of 1000 will be, just increase the exponent by 1, multiply by, increase this by 1, you have 16 factors. And now if you want to enlist the 16 factors, you have to split the screen. So I'll do it like this. See, I'll write 8 above and 8 below this line. Okay, so 1 multiplied by 1000, this is one pair. Then 2 multiplied by 500, this is another pair. And now keep on doing like this and find out the smallest number which divides 1000. I think next one will be 4, and 4 divided by 1000, 4, if you divide 1000 by 4, you will get 250. And then the next one after 4 is obviously 5. 5 into 200 is again 1000. And then I think it is 8 into 125 is again 1000, and likewise you can go on and on. Next one is obviously 10 into 100 is again 1000, and after 10 it is 20 into 50 is again 1000. See, the gap is narrowing down now. 20 and 50 are very close together, and after that it is 25, and 25 times 40 I think is 1000. How many done? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Oh, job done. And therefore these 16 are the factors of 1000. See, that trick works so wonderfully well. But if the numbers are very, very big, nobody is going to ask you to find the or list down all the factors. Okay. Now what happens if the number here is odd? In all the three examples, we got the number as an even number, right? Now I'm going to take an odd number. I mean, the number of factors will be odd. So suppose you have the number 1764. Okay. So if I just want to save time, so that I have to focus on finding the number of factors rather than prime factorization. So I will tell you the factors of 1764 are 2 times 2 times 3 times 3 times 7 times 7, right? So this is 2 square times 3 square times 7 square, and the number of factors of this big number 1764 are 2 plus 1 3, 2 plus 1 3, and 2 plus 1 3, which is 27 factors. Now see, odd number of factors. These are odd. 27 factors are odd number of factors. Now what happens when 27, you get a number like 27, maybe any other odd number. Also, the thing to understand is you have this number as a perfect square. 1764 has to be a perfect square if the number of factors are odd. So if you check very, very carefully, 1764 is very close to 1600, which is the square root of 1600 is 40. So unit digit is 4 here, so 42, I think that should work, and the factor in the middle will be 42. Now this will be the factor in the middle On the left side of 42, since there are 27, 13 factors will be on the left side and 13 factors will be on the right side of 42. Like if you write 1 here, you will have to write 1764 here. If you write 2 here, then 1764 divided by 2 will give you the factor here, which is 882, I think 882. Now keep on writing one factor here and write the corresponding factor here. You will enlist all the 27 factors of 1764. Not easy, but easiest way to write all the factors and not to miss out on any factor. Okay, let's take more bigger numbers. Suppose you have a number like 63888. Now if I make factors of this, this is 2 times 2 times 2 times 2 times 3 times 11 times 11 times 11. Now this is the prime factorization of this number. Converted into exponential form, 2 raised to power 4, 3 raised to power 1 and 11 raised to power 3. And so the number of factors of this big number will be, increase this by 1, 5, increase this by 1, 2 and increase this by 1, 4. So 5 2s are 10, 4s are 40 factors. Oh my god, 40 factors is a big number, right? And so nobody is going to ask you to list down, and you will have a slash 20 factors on the left and 20 factors on the right of the middle, right? 40 factors. And if you have a more bigger number like 108045, you just need to make prime factors. Now that is the most important thing. So the prime factors for this are 3 times 3 times 5, which is 45, and further you have 7s. So 7 times 7 times 7 times 7. So you can find out the number of factors now. This is 3 square, 5 power 1 and 7 power 4. So the number of factors of this number 108045 will be, increase this by 1, 3, increase this by 1, 2 and increase this by 1, 5. So this is 6 5s are 30 factors. 30 factors means 15 on the left and 15 on the right, and that's it. So these are basic things which you need to understand to avoid making mistakes in the exam and finding the total number of factors of big numbers. See, enlisting will only be done in case of 2-digit and 3-digit numbers, not for at least 4, 5, 6-digit numbers which will have big number of factors. So you can do some research on this and let me know in the comments here, did this work and did this actually find applicability in whatever you are studying, and take up 30-40 such examples. And if it does work for you, do share it with all your friends on your WhatsApp groups so that they can also enjoy this trick. All the best for your practice.